Okay, so for this review, we're going to go over congruent triangles, and we're going to use our properties of, let's write this down, side, 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 angle, side, angle, side, angle, 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 side, and HL to figure out if pairs of triangles are congruent. And we're also going to use other angle pair properties as we see throughout the problem. So let's look at number 1. It says in the diagram below, AKS and NKC and AN and SC are drawn such that AN is congruent to SC. We can also say that because these two lines are intersecting, we automatically have vertical angles. So we have a pair of sides, a pair of angles. Okay, says which additional statement is sufficient to prove that triangle KAN is congruent to triangle KSC by angle, angle, side. So based on how they're ordering the letters, and the fact that we want angle, angle, side, I already have a side and an angle. If I want angle, angle, side, I either need these two angles to be congruent, right? Or I would need these two angles to be congruent. Based on the order of letters, right? Angle A has to be congruent to angle S. Angle N has to be congruent to angle C. Now, these two angles, from what I'm seeing, look to be alternate interior angles. So, since they're alternate interior angles, that means that these two sides have to be parallel. But we'll get there. So let's start looking at the choices. It says AS and NC bisect each other. Now, when two lines bisect each other, they produce some type of side, some type of congruent side. Now, we don't want additional information to give us a side. We want additional information to give us an angle. So we're definitely going to be crossing this out. See, K is a midpoint of NC. So this is the same idea. This is going to produce sides that are congruent, not angles. AS is perpendicular to CN. AS and CN are perpendicular. Well, that's helpful, but we already have our vertical angles established based on the information in the problem prior to that. So that's going to give us an angle, but not the angles we want. AN is parallel to SC. Well, as said before, if we want these angles to be congruent, they need to be alternate interior angles. That means that these lines need to be parallel. So this is exactly what we're looking for. All right, let's move on to the next one. Now, for those of you that are in my class, we actually skipped this question. But for those of you that are still curious about this question, we're going to go over it right now. So in the problem, in the accompanying diagram, we have CA and AB are perpendicular. ED and DF are perpendicular. ED is parallel to AB. That means we have alternate interior angles. So if you were to extend the line, you would get two parallel lines, and then these would be your alternate interior angles right here. Then it says CE is congruent to BF, so CE is congruent to BF. That tells you that AB, I'm going to put two dashes here, is congruent to ED. And that the measure of angle CAB equals the measure of angle FDE, which is 90 degrees. All right. Now it says which statement would not be used to prove that triangle ABC is congruent to DEF. So let's look through it. SSS. I already know that I have one pair of congruent sides. And I can figure out the second pair of congruent sides because I know this and I know this are congruent to each other based on what they give. Because they share this one side, I know whatever this length is, I know whatever this length plus this length, and the total length here is going to be equal to this length plus this length, the total length here. So in the end, I can say something like CB is going to be congruent to EF. I can say something like that if I were to prove it. So that technically gives me another side. But I don't have enough information to say that this side is congruent to this side. So I definitely can't use side, side, side. But let's work through the other multiple choice. Now, side, angle, side. Well, because I am able to say that CB is congruent to EF, I have my side, angle, and side here. So that definitely does work. Angle, angle, side. Let's see. Oh, I can ignore this piece and I can just say angle, angle, side from the give the information that I figured out earlier. So this is a possibility, and I want you to keep in mind that even though you only need 3 pieces of information to prove that 2 triangles are congruent, if you're given multiple pieces of information, like here I have 1, 2, 3, 4. I have 4 pieces of information. I can use any combination of congruence theorems as long as I just pick one that mathematically aligns with what I have labeled. Now let's go to HL. HL requires the hypotenuse, which is CB, and the leg, which is AB. So I have 2 pairs of congruent hypotenuse. I have 1 pair of congruent hypotenuse and 1 pair of congruent legs. This also works. So no, choice 1 is going to be the only one that we just can't find enough information for to prove that CA is congruent to DF. Okay, so let's move on to the next one. It says, in the accompanying diagram below of triangles BAT and FLU, angle B is congruent to angle F. Right? Notice that I'm labeling my diagram immediately based on what they're giving, and BA is congruent to F. See, it's funny, I'm talking about labeling, but I'm labeling incorrectly. Please label correctly. Line segment BA is congruent to line segment FL. All right, get it together. So, which statement is needed to prove that triangle BAT is congruent to triangle FLU? Okay, as mentioned before, we have to know these congruence theorems off the top of our head. It says angle A is congruent to angle L. Let me actually mark this in pen, just in case I need to erase and change my answer. Angle A is congruent to angle L. Okay, that's angle side angle. So that definitely works automatically. But let me look at the other choices. Let's see. AT and LU are congruent. So boop, boop. This is angle side side. Definitely not. I'm going to write it this way. I'm not going to write it the other way. But this is definitely not enough. Not a proof at all. We have angle A congruent to angle U. That's not even the same thing. This is angle side angle. This is angle angle side. So they're not even the same. Congruence theorem. So cross that out. BA is parallel to FL. Even though this could look true, like you could extend the line or whatever, because there's no actual transversal running through them, that information is not helpful at all. And so we're actually going to cross that out too. So that means choice 1 is our answer. All right, let's look at the next one. As shown in the diagram below, AC bisects BAD. So AC bisects angle BAD. So we're going to mark that these 2 angles are congruent. And then angle B is congruent to angle D. Angle B is congruent to angle D. Now it says, which method could be used to prove triangle ABC is congruent to triangle ADC? Well, side, side, side. Well, I definitely don't have enough sides. So I'm going to cross that out. Angle, angle, angle. This is never used to prove any congruence. This is similarity. And it's really just angle, angle when you're proving similarity, but definitely not what we want. Now, side, angle, side. Now, I don't have any sides labeled. I rule this out without really talking about this, but the question is, can I mark a side that's congruent? Because all I have are angles, and if I need to prove congruent triangles, I definitely need a side. Now, there's no information in the problem to tell me that BA is congruent to AD or BC is congruent to CD, even though it looks like it. But I do know that when 2 triangles share a side, that side is what's congruent between them because it's the same side that they share. So I actually have an angle side situation going on in here. An angle side is definitely going to be our answer. As I mentioned before, we don't have enough information to talk about the other 2 sides being congruent or whatever. So we're going to cross that out. Let's go on to the last 2. So it says the following. Kelly is completing a proof based on the figure. She was given that angle A is congruent to angle EDF. So EDF right here. And has already proven that AB is congruent to DE. Okay, cool. Which pair of corresponding parts in triangle congruency method would not prove triangle ABC is congruent to triangle DEF? So we're looking for something that's just wrong here. So let's see. AC, let me mark it with a pencil. Let's see. AC is congruent to DF by side angle side. Well, that's actually true based on the markings. Oops, I should have double labeled this, by the way. But it doesn't matter because we're crossing this out. We're looking for something that's false. BC is congruent to EF by SAS. That looks wrong because this looks like a angle side side, which is not what we want. Okay, angle C is congruent to angle F by angle side. That's true. Angle CBA is congruent to angle FED by angle side angle. That is also true. So our final answer is definitely choice 2. Last but not least, we have AE bisects BD. So as I mentioned before, when two lines are bisecting each other, you're only creating sides, not angles. Now, when you see this order, AE bisects BD, right? This is the first line, this is the second line. Only the second line is being cut in half. If it were to say AE bisects BD and BD bisects AE, or AE and BD bisect each other, then both lines are being cut in half. But because you're just given this statement, only BD is being cut in half. So I'm going to mark that BD is cut in half. Okay. Then it tells me that AB and DE are drawn. So AB and DE are drawn. All right. Angle ABC is congruent to angle EDC. Which statement is needed to prove that triangle ABC is congruent to triangle EDC using angle side angle? So I want a statement that's going to give me this, because that's the only place I can put it for angle side angle. If I were to put it here, it would give me angle side. That's not what I want. So I need something to say that these two angles are congruent, or something that can give me the vertical angles result. So let's look at number 1. It says angle ABC and angle EDC are right angles. Not helpful because they're already marked. I don't need that information. BD bisects AE. This is what I was talking about when you need the reverse in order to bisect the other line. So this would actually produce a side, not the angle that I want. So crossing this out. Angle BCA and angle DCA are congruent. This is exactly what I want. These are the vertical angles that I'm looking for. Let's just look at the last one. Angle DEC is congruent to angle BAC. This would have given me angle side, which is not what I want. So definitely choice 3. And that's pretty much it. If you have any questions or comments, leave them in the comment section below. Like and subscribe, and I'll see you later. Bye.